Hello students, welcome to Vyas Education Kota. In this series of NCERT discussion, we'll be beginning the exercise 4.3 from Mathematics class 12th based on the chapter Determinants. Today is the turn of exercise 4.3 and we'll be discussing all the questions associated with this exercise one by one. The topics that are covered in this exercise are related to application of determinants, something called area of a triangle. Yes, how do you find area of triangle given the coordinates of 3 points, and given the area, can you find some condition on the coordinates, or on the other hand, given that you have 3 points which are collinear, what's the condition in terms of determinants, right? In the form of determinants, what's the condition related to that? On the basis of that, you can also find the equation of straight line passing through two given points. Now all of these things have been covered in this exercise over here. This is a relatively simple, easy exercise, small exercise, and we'll be covering them one by one. Let's say the first question that we have is, find the area of the triangle with vertices at the point given in each of the following. Now, what are we supposed to do in this one? Not much. We are simply supposed to use the idea of determinants to find the area. How can you find the area? For a triangle having vertices A, x1, y1, B, x2, y2, and C, x3, y3, the area of the triangle can be found very easily. Area of triangle ABC will be equal to 1 by 2. 1 by 2, yes, there's a factor 1 by 2. And then you write the vertices x1, y1, 1. This is the determinant. This is the 3 by 3 determinant that you get using the vertices. Vertices x1, y1, x2, y2, x3, y3 over here. Right. And you multiply with a 1 by 2, and this is the area of the triangle. Mind you, this value of the determinant may come out to be negative. But remember that area is positive, so you'll have to take the absolute value of this. This particular determinant may come out to be negative, so in that case, you'll have to focus on taking the absolute value since area has to be positive. Has to be greater than 0, right? So in case you get a negative answer, convert that into positive by taking the absolute value, right? Okay, so let's try to find that area. We are given the vertices 1, 0, 6, 0, and 4, 3. So area of triangle will be equal to what? Half of the determinant will be 1, 0, and you have a 1, 6, 0, and you have a 1, 4, 3, and you have a 1 over here. And this is what you'll have. You have 1, 1, 1 over here, x1, y1, x2, y2, x3, y3, and you have a half multiplied over there. What else? We are simply supposed to solve this determinant. This is half, which is okay. The value of the determinant can be found very easily by expanding along. Yes, this column over here, this column has 2 zeros, right? So we'll just need this 3, term having this 3. So what will be here? Plus, minus, plus, and this will be a minus. So minus 3. Actually minus 0 plus 0 and minus 3 times the determinant of 1, 6 and 1, 1. This is what we are interested in. This is what we are interested in. Okay, so this is 1 by 2, which is okay. Minus 3 is okay, and this determinant will be 1 minus 6. Yes, and what is this? This is minus 5 times minus 3 is 15 by 2 is what you get, and that's my answer for this question. 15 by 2 is the area of this triangle over here. Is that all? Yes, that's all in this question. Let's move on to the next one after this. Once again, we are supposed to find the area of this triangle over here having the coordinates 2, 7, 1, 1, and 10, 8. Now, how do we go about finding the area? The approach is once again very easy and simple. Directly find the area using determinant. Okay, the first vertex, as you can observe, is 2, 7. So we'll write 2, 7. The next is 1, 1, and the third one is 10, 8. The third column will be 1, 1, 1. This is what you'll have. Is that okay? Yes. What else? Let's take a look at this. This is, once we have written this much, then we can use properties of determinants, or we can directly expand the determinant. Both the approaches are okay. That's not an issue. So which one do you think we can use? There are many ones over here. We can use properties and try to convert them into zeros. Yes. Let's try to convert them into zeros. 1 by 2 is okay. 2 minus 1 is 1. 7 minus 1 is 6, and 1 minus 1 is 0 over here. Yes. Okay. 10 minus 1, 1 and 1, let it remain as it is. 10 minus 1 is 9, 8 minus 1 is 7, and you have 1 minus 1 as 0. This is what we have. Is that okay? Yes. And now we can expand along this column and we get the value of the determinant very easily. What you get is plus minus plus, plus 0 minus 1 times determinant of 1697 and my plus 0. This is what you get. Is that okay? Yes. Therefore, area becomes equal to what? Half of this determinant over here. This is minus 1 times 7 into 1, 9 into 6. Okay. 7 minus 9 times 6 is 54. 7 minus 54 is what I get. 1 by 2 is okay. Minus 1 is okay. And then you have 7 minus 54, which is minus 47. This is what you get. Minus 47. And this will give me actually 47 by 2. That's the area. That's the area that we get. That's my final answer for this question, as you can clearly see over here. Is that all? Yes, that's all for this question. Let's discuss this question next. The question says find the area of triangle. Yes. And the 3 vertices are given. Minus 2 comma minus 3, 3 comma 2, minus 1 comma minus 8. So what are we going to do? We're going to do a similar thing as we have been doing up till now. And area will be equal to the determinant. Area will be equal to the determinant half times the determinant of this minus 2 minus 3. This is what we'll have. 3 2 minus 1 minus 8 is what we'll have. 1 1 1 is what we'll have over here. And this is the area for us. Okay, in case the value is obtained negative, we'll take the absolute value obviously. And let's see. Since there are a lot of ones, one thing that we can do is try to create some zeros first of all before expanding. Another idea is to expand directly without worrying about anything along any row or column. So what I would like to do is, I would like to create some zeros first, right? Let's try to create some zeros. Okay, let's take minus 2, minus 3, 1. Let it remain as it is. 3 minus or minus 2 will become 5. 2 minus or minus 3 will become 5 and this will be 1 minus 1, 0. Is that okay? Yes. Next. Minus 1 minus of minus 2 will become 2 minus 1, which is 1. Minus 8 minus or minus 3 will become plus 3. Therefore, minus 8 plus 3 will be minus 5. And you have a 0 over here. 1 minus 1 is 0. Is that okay? Yes. That's pretty simple. What else? I can create some 0 here also, but another thing that can be done is simply expand along this column. And if you expand along this column, what you'll get is this. 1 times the determinant that you'll get is 5. 1, 5. Minus 5, okay, minus 0 and plus 0. This is what you'll get. Is that okay? Yes. Therefore, area will be equal to what? 1 by 2 times 1 times this determinant, which is minus 5. 5 into minus 5, minus of 1 into 5, which is minus 25 minus 5. And obviously, we'll have to take the modulus, the absolute value. And since we have to take the absolute value, what we'll get is, this is minus 30 by 2, which is minus 15. The modulus will be equal to 15, and yes, that is my answer for this question over here, right? Is that okay? Yes, that's okay. That's all that you have in this question. Oh, you brought that modulus out of nowhere? No, I did not bring it out of nowhere. I simply said that you have to take the absolute value. So modulus was always present over here, just that I have not written it over here directly, right? That's all that you have in this question. Let's move on to the next one after this.